Hello everyone, and welcome to Project March 6's design presentation. During this design presentation, we will tell you about why we exist and what it is that we do, as well as show and explain the specifics of the March 6 exoskeleton. During the main stage presentation, you will have the opportunity to ask questions in a chat on the right of your screen, which we will aim to directly answer during the presentation. Afterwards, there will be an information market, where you will have the opportunity to ask questions about the specifics of the exoskeleton or general questions to the management team or pilot. I thank you all once again for being here, and I hope you will enjoy this design presentation. Think about the amount of times that you stand up and sit down daily. For good health, doctors recommend that a person stands up and walks around at least 40 times a day. But for 150,000 people in the Netherlands alone, this is an impossible task. The reason? They're wheelchair-bound. Of those 150,000 people, 13,000 are wheelchair-bound due to a spinal cord injury. For these people, the most mundane activities, such as going to the toilet or taking a flight of stairs, are a challenge each time again. Project March has a mission: change the quality of life for people with spinal cord injury for the better by enabling them to walk and stand up once again. And we do this by designing and building a prototype exoskeleton, or motor-assistive robotic chassis for humans. An exoskeleton is a robotic suit that can empower someone that has no muscle function in their legs and lower core. With the help of actively motorized joints and well-fitting fixture, someone with paraplegia can therefore be empowered to stand up and walk once again. Our specific focus group are people with a complete spinal cord injury. When someone has a complete spinal cord injury, the nerve pathways are interrupted, which induces a loss of sensation and muscle function below the place of injury. Walking, standing, and many other functions are therefore made impossible, and these people are wheelchair-bound for the rest of their life. But along with the loss of sensation and the loss of mobility, a complete spinal cord injury can also induce other complications, which are called secondary symptoms. Examples are poor bowel and bladder function, deteriorated blood circulation, and weaker bones. Especially the loss of control over bowel and bladder function can cause great discomfort and shame for the paraplegic. These secondary symptoms are invisible, but often they are the most bothersome complications that people with paraplegia have. An exoskeleton can help. Not only can it make sure that a person with paraplegia can stand at eye level with their loved ones once again, it can also improve their mobility to near normal, and it can actually help with the secondary symptoms as well. Therefore, an exoskeleton can help with the physical complications as well as the mental health problems and other emotional problems that paraplegics can have. It is important to emphasize that for Project March, the exoskeleton will not ever replace the wheelchair. Indeed, an exoskeleton can be seen as an assistive device, which in a paraplegic's life can be implemented parallel to the wheelchair. The combination of the two devices can lead to the most healthy and mobile lifestyle feasible for a paraplegic. In this light for Project March, the importance of the development of exoskeleton technology is evident. It is important for us to do our part for people who have suffered from traumatic injury and help them regain some of their mobility and other physical and mental benefits. And exoskeleton technology has been rapidly advancing throughout the past couple of years. Various teams and commercial companies have been working with us toward this common goal. And we have actually even competed against some of them in various competitions. But there's still a lot of innovation that can be achieved. and Project March is very proud of its high and effective development pace. We have been aided by, for example, various rehabilitation clinics, such as the St. Mark's Clinic, as well as pilots from the previous Project March teams. And Project March is a special team, also because we are the only team that consists entirely of students. Since the Project March teams are annually recruited, we have a very fresh take on exoskeleton technology and innovation each year again. This enables us to break technological boundaries each year again. The Project March students do this by dedicating 13 full months towards designing and building a prototype exoskeleton, breaking technological boundaries, and raising awareness about paraplegia and exoskeleton technology. All of the students set aside their degree for an entire year so they can focus wholly on a common goal. Normally, we would be in our workspace in the Delft University of Technology, the Dream Hall. However, currently our offices are located in Robo-Valley. Both the Dream Hall and Robo-Valley aid us in our quest, and we are very thankful for the collaboration with both, which we relish to cultivate further in the forthcoming years. As of August 2020, a new team has been rising to the challenge for the 6th time. Project March 6 consists of 26 students from various backgrounds within the Delft University of Technology. They come from all disciplines, electrical engineering to nanobiology, and from industrial design engineering to life science and technology. The combination of these various backgrounds, interests, and disciplines make sure that the project is the best it can be. And then there's our 27th and our most important team member, our pilot. This year, our pilot is 33-year-old Koen van Zeeland. We've been brought into contact with him through the St. Martin's Clinic in Nijmegen, where he had his rehabilitation. We work in close collaboration with Koen, so that we can respond to his wishes the best we can. Together with him, we hope to make an exoskeleton that is as user-friendly and as practicable as possible. By working together for a full year, the team ensures that we have a strong bond with each other. Normally, we would be working in our workshop at the Dream Hall and in our offices at Robo-Valley. But due to the pandemic, also we have been forced to start working from home. But we've aimed to make the best of it anyway. By starting and finishing the day, all of us together, by staying into close contact through Zoom and through Discord and taking long walks with each other, we are still working as one big team. Although COVID-19 changed our situation drastically, we have not been put back, and we have worked with determination to achieve our goals.
But what are our goals precisely? All prior March teams work towards a cybathon. This is an international competition in which powered exoskeletons from all over the world compete for the title of Best Exoskeleton. The cybathon is based on situations people with a spinal cord injury encounter in their daily lives. The competition centers around overcoming 6 specified obstacles in the shortest possible time, some of which you've seen in the introductory video. Since these obstacles are fixed, contestants program their walking patterns beforehand. The pandemic gave us cause to thoroughly reevaluate the goal that is set each year and look past the cybathon competition. We presented ourselves the following question: how can we innovate exoskeleton technology to allow paraplegics to benefit from it in their daily lives? In the last couple of years, advances in exoskeleton technology have rapidly succeeded one another, enabling more individuals to use exoskeletons as training devices in clinical settings, improving their health. Suddenly, the idea of exoskeletons actually becoming available to support daily life does not seem so far-fetched. Exoskeletons currently under development all excel in different aspects. For instance, there's one exoskeleton that does not require crutches to maneuver. Another one costs less than $50,000, and yet another one is already CE and FDA approved for personal usage. All these different teams around the world are taking major steps into becoming more serviceable for paraplegics. However, as we see it, there's one area that inevitably needs innovation to transition from a training device to an assistive device, which is the step outside. For an exoskeleton to be useful in daily life, it should be able to take you from one place to another. And more often than not, That path does not look like this. The real world is full of obstacles that are not flat or standardized. Therefore, a need arises for exoskeletons that are capable of anticipating and reacting in real time to the environment their pilot directs them to. This year, March 6 takes upon itself the challenge to take a step in this direction by moving away from pre-programmed gates and devoting ourselves to making exoskeletons more versatile. Therefore, our stated objective is to develop an exoskeleton that allows our pilot Koen to dynamically walk a route through Delft coming summer. And by dynamically, we mean not making use of predetermined specifications or dimensions of the route. Arguably, the biggest challenge arising from this team goal is creating walking patterns dynamically. These walking patterns are also called gates. And how it currently works is the pilot presses a button on the input device, after which a pre-programmed gate is played that has a set step size and trajectory. One can imagine that when facing an unknown terrain, a different strategy is required. The next location of the foot must be chosen very carefully to maintain balance. Gates cannot be pre-programmed or constant anymore. They must be created real-time, dynamically. And this major challenge does not only apply to walking, but also to climbing stairs, sitting down on benches, and standing up from them. In addition, our team goal challenges us to increase the operating time of the system, to enable Koen to complete a lengthy route through Delft. This factor is not only influenced by the battery life, but also by the amount of effort it takes the pilot to walk in the exoskeleton. Currently, this requires quite a lot of strength and endurance. And because we want to shift our focus from a training device to an assistive device, we want Koen to be able to comfortably walk in the exoskeleton without feeling winded. Now that you've become acquainted with our team goal and its main challenges, you're probably quite curious about how we plan on overcoming them. Without further ado, we present to you the design of the March 6 exoskeleton.
We proudly present to you the new exoskeleton design of March 6. Our goal was clear. We want to design a unique exoskeleton, one that walks dynamically. And we also aim to increase the value for our users by designing for daily use. We do not want to go faster, but we want to go where we have not been before, outside. And to achieve this goal, we had to face these two main challenges. We had to reinvent how we walk, from pre-programmed to dynamically. Our main challenge, derived from going outside, revolves around one thing. How do we conquer an unknown terrain? How do we predict the height of a stair, of the angle of a slope? The exoskeleton has to gain information about the environment and use this data to calculate and predict its next steps. So we implemented a depth camera. This depth camera serves as the eyes of the exoskeleton. Similar to the biological process, the camera extracts information from images, and by comparing those from two different points in a scene, it can contract 3D information. This is called computer stereo vision, and our software can use this data to create regions where the exoskeleton can walk and calculate how to adjust the step size. This is the beginning of a generation of exoskeletons that walk dynamically. Due to the challenge of an uneven terrain, balance becomes even more important than in the previous years. So the exoskeleton has to know on which foot the pilot's weight rests, because lifting this foot will increase even more instability. And to know on which foot the pilot's weight rests, we implemented pressure soles. These soles measure the pressure on 8 different locations of the foot, so we can estimate very accurately the balance of the pilot. We use these sensors to adjust the walking patterns, but these walking patterns also need to be designed. We try to create walking patterns that look and feel natural, so the pilot's efforts can be reduced. These designs are based on research and the performance during training. But it's very challenging because the exoskeleton's degrees of freedom are limited compared to the ones of a human body. So the pilot is limited in his movements. A human body has 7 degrees of freedom and our exoskeleton only has 4. So you can imagine that walking precisely like an unimpaired human being is rather impossible. However, we tried this year to use a totally different approach and use these constraints as a starting point. We, together with our partners, developed a suit that obstructs the human body similar to our exoskeleton. And we observed how a person would walk in an exoskeleton, and these movements are the basis of our new walking patterns. Naturally, our exoskeleton has to be designed so it allows to perform these walking patterns. So we have to optimize our whole design. The joints are of paramount importance. They serve as the muscles of our exoskeleton. And we have implemented a motorized hip, knee and ankle. Compared to the previous years, we have a radically new design of the rotational motors. Those are thinner, but more importantly, able to reach higher torque. It has been increased with 70%, up to 250 Newton meters. And this is important because the joints now can reach a higher speed, so they can react quicker to the information from the sensors. So the pilot's efforts can be reduced. Let's dive a little bit deeper into our joint design. The performance of the electronic motors are coordinated in a predetermined way by the motor controllers. And to increase the reliability of our exoskeleton, we selected a new open-source motor controller called the O-Drive. And we are happy to contribute to its firmware. Moreover, we also implemented a new control method called model predictive control. And the dynamic models of the joints enable us to predict and to optimize their future states. So we are able to estimate the right amount of torque so the gates can be performed. Our exoskeleton can now anticipate on the movements rather than react on a possible error. So this actually means that the exoskeleton can walk smoother. If we look at our overall software development, we took upon some very nice innovations and improvements. We optimized our software to the latest upgrades in the firmware of robotics. We also selected a new computer which is more powerful, and that's why it's able to make more complex computations every data cycle. And this was necessary because we are collecting more and more data due to our sensors. So our new rotational Jones design doesn't only impact, for example, the torque, but also the placement of our electronics. Because due to the design, there's no space left, for example, on the upper leg. So we have to use this space very carefully. We don't only have to use our space very carefully, but also the material. In the frame design, we optimize the material use by using topology optimization in 3D. We did not only decrease the weight, but we also were able to bear all forces safely. Another great example is the carbon footplate, which is also flexible. It's lighter and it's able to deform to the motions of the foot. So our second main challenge revolves around designing for daily use. And if you're designing for more user-friendliness, new requirements arise compared to a one-time run for a competition. Our exoskeleton should be able to be used for a longer amount of time. That's why we doubled the battery capacity, so our exoskeleton can walk further. But we also thought of the ease of use. That's why the battery, which is located in the backpack, can be easily removed due to a quick release mechanism, if, for example, it needs to be recharged. The power distribution board is also located in the backpack. And this board reassures that all electronic components receive the right amount of power from the battery. And we made this board very compact because we optimized the placements of the components. Because in the backpack we're trying to save use, so every centimeter counts. But these electronic components and the structure need to be protected. They need to be protected from the outside world. So we made sure that dust cannot enter and water is guided away from any openings by designing 3D tailored covers. These covers serve a dual function. They do not only protect our exoskeleton, but they also determine how the exoskeleton appears. That's why in the outdoors context, we decided to make the look and feel of the exoskeleton robust, so that Koen feels free to walk around without having to worry of damaging it. We are now wanting to show you a very cool new feature, which is called the hinge. Our scope allows us to focus on user-friendliness. So this user-friendliness can be applied when walking in the exoskeleton, but it's also, our scope creates the opportunity to focus on the transfer from the wheelchair to the exoskeleton and the other way around. And with the hinge, the pilot is able to move the legs another 60 degrees apart, creating more space. This makes the transfer easier, faster, and safer. The fixtures are the connections between the pilot and the exoskeleton. We've shaped these fixtures exactly to match Koen's body. The upper legs fixtures have been improved with a new connection mechanism and a new closing mechanism, both contributing to a faster, easier, but most importantly, more comfortable transfer. The lower leg fixtures, there we see the biggest design changes, because we turned the design around. We changed from fixating the chins to the calves. And we did so because this is a less sensitive part of the body. The torso fixture has been enriched with a pouch. This has been done in an effort to prepare the exoskeleton for daily use and to make it user-friendly. Within the several components, Koen is able to carry his wallet, his phone, and a ball for his dog with him. The last contact points between the pilot and our exoskeleton are the shoes. And the shoes are cut open so the foot can enter from above. And the outer sole has a heel and a collar. Both support Koen when walking in uneven terrain in the center of Delft. This year we started a unique project, and it revolves around how the pilot controls the exoskeleton. Now, the movements of the exoskeleton can be controlled via an input device located in the crutches. And the previous years of March has developed this almost optimally. So this year we only had to adjust the design to the preferences of Koen, our pilot. But there's still so much to gain. That's why we want to challenge the status quo and are exploring a new method of input called EEG. With EEG, you can measure the brain activity of people. So, our pilot only has to think about walking and the exoskeleton walks. No need to push any buttons anymore. Despite exploring new possibilities of an input method, we are also investigating new ways of providing feedback to our pilot. Smart glasses appear to be promising, as they allow us to move the display from the crutches into the field of view. So our pilot can keep his eyes on the road and stays aware of his surroundings, which can be very useful during daily use. As you can see, we're exploring a wide range of possible futures. And we're only halfway through our journey, because from now on, we'll be working hard to bring the exoskeleton to life. So we can really start to add value to people's lives while revolutionizing exoskeleton technology.
And with this, we would like to conclude the general part of the Project March 6 design presentation. We hope you have all enjoyed, and we hope that to see all of you at the end of August, when we will walk our route dynamically through Delft with Koen. Of course, with the exception of the stairs, this entire route can be also performed with a wheelchair. But we think that the possibility for a paraplegic to choose whether to walk or to roll this route is the most important thing that we can give to someone with a spinal cord injury. Now there will be an information market. There will be 2 sessions. For each session, you can choose which stand or topic of preference you want to attend. In each stand, a team member will give a presentation of a specific part of the exoskeleton. We thank you all for being here, and we thank everyone who helped us in making this design presentation and the March 6 exoskeleton possible. We hope to see you all during the information market, and thank you all for attending the March 6 design presentation.